So what I will try and do, I'll talk about a basic case, and I guess you guys have already seen that. Have you done something called the prisoner's dilemma? So I'm just going to give an example of prisoner's dilemma in the context of microeconomics. The prisoner's dilemma story, the payoff doesn't matter. What simply is that there were two guys for a time. I mean, I'm giving one person, there will be multiple persons. One guy for a time, they are put into separate cells, and then each of them are whether you confess to the crime or you don't confess to the crime. So the players have strategies, not confess or confess, not confess or confess. Okay. And then you have a set of payoff. That depending upon if the other party says confess and you say not confess, how much you get, etc. And the outcome which you get is something like confess and confess outcome. So there is a payoff that both of them get 6 months of imprisonment. But had both of them not confessed, both of them would have got 40. So minus 6 is really bad. 6 months of imprisonment. Not confess is going at it is costly. But the game is such that if you make it play, then the individual will end up on the confess and confess. So this is what is basically we call as a dominant strategy equilibrium. We call it a dominant strategy equilibrium because that confess outcome in this game happens irrespective of what the other player is. So this strategy is dominant. So this is almost an equilibrium which should not be a part of game theory. Because game theory talks about a strategic interaction. How would I react given what I think you will do? A dominant strategy, it is I will react in this way irrespective of what you do. The dominant strategy is not really a part of game theory, but that's the way to think about it. But indeed it is actually studied under this. So that is the dilemma. Why it kind of people like it and people use it in a various examples here? We talked about two things. This is a game theory equilibrium, this is about dominant strategy, this is a game theory equilibrium. And then we have something called a Pareto optimal equilibrium. A Pareto optimal and Pareto efficient equilibrium. You might have done the Pareto equilibrium. Pareto efficiency equilibrium is equilibrium which is built for the agreement. So one way to look at Pareto or the definition is that is a Pareto optimal allocation, that is a Pareto optimum outcome between two parties where you cannot make one party better off by not making the other party 60 worse. That's the Pareto contribution. The theory is 0, both of us will be better off, then minus 6. But what game theory and physical dilemma in particular tells you is the fact that you cannot from minus 6 go to 0. That is the strategy. What I will try and do is I will try to look at a very simple game in the application that where do we apply game theory or in what form can we apply game theory. So for that I know you have told me that we have already done full row competition. We have also done monopoly competition. Monopoly and full row. So let's kind of try to create a simple example. Suppose we have an inverse demand function. The P equals to let's say 10 minus 1 Q. If it was a duopoly, then the demand function would be 10 minus Q1 plus Q2, where Q1 is produced by one, Q2 is produced by the other. If it's a monopoly, there is only one. Let us assume that the total cost of production, the cost of production is equal to 0. So it is a good old example which one is just to make the mathematics simple, if I have going to change anything, which is that drinking water, spring water. It's the cost of production of that is equal to 0. So we are ignoring what other costs are going up to correcting down. So suppose there was a monopoly firm. The question is, what would be the Q star for a monopoly firm? and what will be the profit for the monopoly? For a monopoly. Come up quickly. You guys are done it. What will be the future or what will be the profit? How do I formulate it? Profit for a monopoly is going to be price times Q minus C times Q. This is already equal to 0. By construction, it will be price times Q. What is price? N minus Q times Q. So the profit maximizing output will be whatever Q is maximizer. So that will be N minus 2Q star. This is the first order condition. That equals to 0. So Q star equals to 5. And therefore what is the profit? 5 star. 5 star is going to be 5 times 5 is 25. Therefore the monopoly. Okay. So let's try to represent that in a 2 by 2 box. The objective which I have to do in this I'm going to show that the Kuno outcome, either gain-theory or statistically, the only outcome is. That's what I'm trying to argue. And I'm going to go it by the 2 by 2 box, exactly the way we have done this in the diagram. So, have this box. Suppose it was this, the for monopoly. The beginning with 2. So monopoly outcome Q is equal to 5, profit is 25. Now let's look at it. Low-poly outcome. So what will that be? For individual 1, it will be price times quantity 1. For individual 2, will be price times quantity 2. The cost of producing something I exchange it to be 0. So this is going to be N minus Q1 minus Q2 minus Q1 for individual 1. Again, if I do the first order condition, it will be N minus 2Q1 minus Q2 star equal to 0. I can do the same for the second individual. So for that second individual, this will be by symmetricity will be minus Q1 star. So Q1 star will be equal to Q2 star, and what will it be equal to? 10 by 3. If this is 10 by 3, then what is going to be the profit of one particular firm? Is that it will be 10 minus 2 by 3 times 10 by 3, right? Sorry, 20 by 3 by 10 by 3. So that's 100 by 9. This will be for both of them. So let me now put it. So you have the farm A and the farm B. What are the contemplating? That should I produce a monopoly output or should I produce the duopoly output? So I can produce a monopoly output or I can produce a duopoly output. It's a Kuno output. Instead of calling it D, I'm going to call it C. Again, I can produce a monopoly output or I can produce a Kuno output. The issue is, if I produce a monopoly output and the other party also produces a monopoly output, then what happens? We both of us produce a duopoly output, what happens? That is static interaction which we are doing. So which are the, this is A and this is B, which are the two players who are playing. So first, if both of them are producing a duopoly output, then how much will they get? One will get 109, 100 by 9, the other will get 100 by 9. That's duopoly. Now, Suppose what happens is one of the individuals decides that instead of producing the duopoly output, if I produce the monopoly output, what will I get? So that is, one guy decides to go with the monopoly output, the other guy decides that no monopoly output, but I will do duopoly output. So then, for if the individual one, let's farm one, farm and two. The farm one decides that I am going to produce the duopoly output. What was the duopoly output? Take 10 by 3, right? An individual but 10 by 3. What was the monopoly output? 5. It was 5 and it was 10 by 3. Okay, so this is different. Now, the issue is, these two firms have two strategies, two broad strategies. One is to be compete, like the duopoly. The other is to do the following. Suppose we join hands and we become a monopoly. We don't fight. We call you, we become a monopoly. And then what we do is we try to divide the profit of after being a monopoly. Whatever profits we get, being a monopoly, we try to divide the profit. The first observation, which one do you think will have a higher industry profit? The Kurno, sum of the two firms competing each other and adding their profit, or is the being as a monopoly, that profit? So let me rephrase the question. I am giving you two scenarios. In one, where two firms A and B decide to become like a monopoly, and they are going to distribute the profit among them. In this case, there is an industry profit. What is the industry profit? The profit of the monopoly. In the case 2, these two firms in the same industry are not going to join hands and behave like a monopoly, but they are going to fight. This is also going to give a profit. Industry profit is separate. Which one do you think will give a higher profit? Monopoly or the duopoly? Right. That doesn't matter. That is those are numbers that they are in the board. So monopoly profit is higher in economics is not because the math is that. It has to be an indication. If you could explain that.
No, also it depends on the type of program. That program is very sensitive, but they have the power to change the prices and they have a control over the market. They can charge a premium as to what they want. Whereas when it comes to competition, they have to fight among the market. And in order to compete, they have to set the prices for the
issue is in a monopoly. Can you charge any price you like? No. Because if you have a negative demand function, if you increase your prices, you will buy it. So you don't know.
And they both agreed to quote the same price, at least a big image. So relatively they will be better off than compared to company.
Why can't it be the case that both of them in the fighting agree on the same thing? In other words, is the monopoly industry profit higher than the oligopoly industry profit? Practically, the answer is yes, it is higher. The logic is very simple. The proof for the logic is the following. Suppose that's not the case. That monopoly profits are not higher than the industry or the duopoly profit. If that was not the case, then the monopoly can now divide itself up and start behaving like a duopoly. If a monopoly finds that the 4-firm competition is giving a higher industry profit than a 1-firm competition, then what stops from a monopoly to divide itself into 4 firms and competing and get the same profit? So whatever the duopoly or the oligopoly can do, the monopoly can always do that. The monopoly profit in this direction will be greater than the industry duopoly profit. The question is, can the 4 firms who are fighting join hands and become the monopoly? We are not sure about that. We know there is nothing which stops the monopoly to pretend that the duopoly with the duopoly profit is higher. is not obvious, or it may not be possible for a duopoly to behave like a monopoly. So a monopoly industry profit is always going to be greater than a duopoly industry profit. If that is the case, then the two firms 1 and 2 must come together, start behaving like a monopoly, and then decide to divide the profits proceeds among them. Equal. So I'm going to take equal. Which means what they can do is the following. They can say, okay, let's behave like a monopoly. This way, if you behave like a monopoly, what's the monopoly output? 5. Then if you're behaving like a monopoly and you're deciding to divide the proceeds among ourselves, then how much must each one of us produce? 5 by 2. So both of us will produce 5 by 2 and 5 by 2. So this is the monopoly collusive also, not the monopoly output, but monopoly collusive also. If that is the case, how much is the profit which we are going to get? Because we found it was 25 was the industry profit, so 25 by 2 and 25 by 2. But now the farm structure. Suppose the farm one decides to do the following. Both of them have decided that they are going to do 5 by 2. Suppose the farm one now deviates from 5 by 2 and instead decides to produce 10 by 2. How much will farm 1 get? So farm 2 is continuing to produce 5 by 2. Farm 1 is deviated and started producing 10 by 2. How much will the 2 farms get? So this one is going to be 10 by 3 and Q2 is going to be 5 by 2. So what will be the case in this case? It is going to be 10 minus 10 by 3 and minus 5 by 2. And how much is the Q1? That's 10 by 3. So how much will it be? So it's going to be 16 minus 15 and 25, right? So that's 25 by 3. It will be 10 by 3. That's 250 by 80. Please check whether my calculations are. Or I can write it here 125 by 9. What happens to the other guy? In this scenario, what happens to farm 2? Farm 2 is continuing to produce 5 by 2. But farm 1 has decided to produce 10 by 2. So what has happened to farm 2? But farm 2, the price will be the same. 10 minus 10 by 3 minus 5 by 2. Only thing that will change is this one. And this will become 5 by 2. So this is 5 by 2. And this is 125 by 125 by 2. By an argument of symmetry, which means if I just now do the other scenario where farm 1 was producing 10 by 3, farm 1 was producing 5 by 2 and the farm 2 had decided to produce 10 by 2, what we will get is this will be 125 by 12 and this will be 125 by 9. So indeed we have taken two extremes. One, we have taken the Kuhn outcome, that it was, and we have taken the other extreme where they could have behaved like a monopoly and decided to divide the profits. That's 5 by 2 and 5 by 2. Now, this is the game which we have. This is a simultaneous new game which we are trying to do. So now I am going to talk about some formal language. Now, when we are talking about game theory, it must have some key things well defined. First, the number of players. That's very important. Number 2 are strategies. What are the strategies I have in this game? There are many strategies, by the way. I have only highlighted 2. Strategies in this case are the output production. Output from 0 to infinity, all of them are possible strategies. I have only picked up these 2 strategies. So you need to have a finite set of strategies. That's all we need. Third, what we need is a rules of the game that is well known. what is the rule of the game here? That we are going to produce something and then in whatever way, and then we are going to get a payoff. That's the rules of the game. Of course, everybody, the payoff should be well defined. Everybody is playing the game to maximize something, they maximize the payoff. In this case, they are maximizing the profit. These payoffs are also well defined. That's the fourth thing which we should do. Then comes some not so obvious things. And these are based on, this is about the information requirement. So step one, first amount of information is that it should be a complete information. This is a game of a complete information. Complete information means that everybody can see everything. For example, this individual one knows that if he plays 5 by 2, he produces 5 by 2, and the other guy produces 5 by 2, both of them get 25 by 2 and 25 by 2. If he plays 5 by 2 and he plays 10 by 3, he gets 125 by 12 and he gets 125 by 9. It should not be the case that he doesn't see these numbers. If that is the case, then it becomes an incomplete information. But you don't have complete information about all these stuff. That's an incomplete information. You also have an important rider about complete information. It's about, what I'm not going to give a technical term, this is about how much I can calculate or how smart I'm the player or how rational I'm the player. So what we are looking at the assumption is the following. And it is easier to take this example. Is that suppose you and I were to play a game of chess. A complete information can be modeled in the following way. You know that you play chess very well. I know that I don't play chess very well. Complete information is the first one. You know you are very good. I know I am not very good. Second round, you know that I am not very good. In third round, you know that I know that I am not very good. You know that I know that you know that I know that I am not very good. This will go as which means that when we are looking at this game, we are kind of imposing the structure that the ability to calculate, the ability to think ahead and take a very rational, informed decision, that is not one problem. So we perfectly know what we are up to against each other. I know that you are a good chess player. I know that you know that I know that you are a good chess player. It's like a lot. Because when you take a particular move in chess, if I think that you don't think that I am a good player, then you will have responded totally differently. Because I think that you think that I am a good player, you will respond in a particular way. So you will be concentrating based on that. It's just not good enough to be yourself a good chess player. It's also what you do will also depend upon what the other guy is also. What you think about the other guy. That's a complete information. We have another set of information requirement. This is a kind of vanilla game. So none of these assumptions are going to relax for this particular case. We have another requirement which is that the game set has symmetric information. So what we mean by symmetric information is this will be the following. Okay. That the type of the player or actions of the player, these are not unknown to each other. So for example, you and I can always play a game where you know your type and I don't know your type. So if we and I want to play this game, you know how smart you are, and if I do not know how smart you are, and if I can take an average or if I just try to play the game blindly, chances are not that I'm going to know. One of the interactions of the genetic information game is between the potential and the image. I don't know how much you have worked hard. Whether you study for 3 hours or you have chaya, shamal, standing, you have night. I have no way of knowing it. Only you know that. So I have to devise a particular way of finding out how hard you are working. If the exam is right way, if exam is only way, and they are supplemented during the exam, those are the part of the game plan. But in this case, we are not going to look at any of those assumptions. We are not going to buy any of the assumptions. Now we have to pay off. So what do you think will be the outcome? Now, this guy, one says that if he plays QM by 2, I can play 25 by 2, or I can play 125 by 2, 125 by 9. If I play 2 no outcome, I get 125 by 9. If I play 50 outcome, I get 25 by 2. What should I do?